Good morning, all of you. Let's start the class. But today I cannot take uh, the full class. I have some work. So let me try to complete this unit as far as we can. That in the last class, GSM channel types, we already, sorry, I'll forget to unmute my microphone. Can you hear me? Is it audible, my voice?
Yes, sir.
Okay. Uh, Good morning, all of you. And today I have some duty, so I cannot take much time. I have to go to this duty. Before this, let
Sorry, sir, I didn't get proper.
hello.
Yes, sir.
Yes, Rajesh.
Yes, sir.
Yes.
Yes, sir.
Any problem?
Yes, sir. Here, internet problem, sir. So I didn't get your voice properly.
You cannot hear my voice.
It's there. Sometimes it's just broken out.
Is it clear right now?
Yes, sir.
Okay, let's go on this GSM channel. Last class we already completed some of the point number A and B. A, point number A. And B is the slow associated control channel. This is the, as the, this is the slow associated channel. In some situations, signaling information must flow between the network and the mobile stations when a call is not in progress. Okay, when a call is not in progress means if it is idle, the mobile devices. If this is idle, the device. Okay, mobile phone. If it's idle, the mobile phones, then this is double SCH is initiate this channel. Okay, and also one more example of this slow associated control channel is the during a location of during a location update. So if there is no call progress and it's needed to update the location also, then it initiates this slow associated control channel during these situations. This could be accommodated by allocating either a full rate or half rate. TCH. What is TCH? TCH already explained in the last class. And by using either the SSCH and FSCH, full and half. Okay, full and half to carry the information. FSCH of associated control channels more urgent in the information. However, hand-off command. Example: a hand-off command is sent using the time slot and are stolen from the traffic channels. Okay, this SSCH is urgent from FSCH is a control channels used in the handover commands. Handover, we already learned this one. If the mobile stations move in a rapid speed or maybe a slow speed to going out from the current cell to the another cell, then it's needed to have a handover to the new cell. So it's incorporated with this associated control channel. Okay, it's sent out using time slot that are stolen from the traffic channels. Okay, if students during the conversations of handover must be performed, if FSCCH is used. If suddenly during the conversations and handover may be performed, so then during the conversations. When we are having a conversations with our friends or relatives, then we are in emotions. Then during these conversations, we need to perform the handover. Then the fast associated control channels FACH is used. Okay, FACH work in the stealing mode, meaning that 2 millisecond segments of speech is exchanged for signaling informations necessary for the handover. So 2 milliseconds means million of seconds of 2 or 2 millions of seconds is used for this handover for signaling information necessary for the next cells. So the time taken is very small, so we cannot recognize that our connection is ideal or not. We cannot detect it. Okay, it's used these 2 milliseconds to hand over those informations. Okay, and let's move on to the next slide. CDMA, digital cellular standard. CDMA is the let's see, is a CDMA is a IS95. Okay, it was the first CDM mobile phone systems to gain a widespread use, and it is found widely in North America. Its brand name is the CDMA1, and the initial specification for the system was IS95A, but it is performed was later upgraded on the IS95B. It is his later specifications that is synonymous with the CDMA1. Okay, this is the name for this CDMA IS95 services, CDMA1, and also it's firstly used in North America, and the first specification is the IS95A, and later on is coming up to the upgraded one, this IS95B. Okay, this name specified the CDMA1, but apart from a voice, hello, is it visible my?
Yes,
Yes,
sir.
sir.
Okay.
So,
Apart from voice and mobile phones, systems is also able to carry data at rate of up to this 14.4 kilobit per second for the IS95A and 115 kbps kilobit per second for the IS95B. So these two are the two specifications used in this CDMA1, and the data rate up to this 14.4 kbps for this IS95A and 115 kbps for this IS95B specifications. So IS95 or the CDMA1 was the first cellular technology system to use the CDMA CDMA code division multiple access system. Previous systems had used this frequency division multiple access or time division multiple access TDMA. With this IS95 being as second generations 2G systems, and all the later 3G systems using CDMA and their access systems, this meant that IS95 CDMA1 was pioneering system. For this latest cellular technologies like a 2G or the 3G, using this CDMA, the pioneer, the leading technologies used is the CDMA1 or this IS95. This IS95 and CDMA is the first technology implemented for this cellular technology in this 2G, and later on is coming up this 3G by using this CDMA. Right now we are using this in our Indian telecommunications. We are not digitized fully our communications, not using this CDMA. Okay, 2G, 3G and 4G also. Okay, let's move on to the next point. CDMA channels can be broadly categorized as forward channels and reverse channels. These chapters explain that the formalities of these channels. Forward channels. What is the forward channels? Forward channels is the directions for the communications or mobile to cell downlink path. This include the following channels. What is the forward channels? Forward channels is the directions of the communications of mobile to cell, mobile to cell phone. Okay, mobile to a cell phone downlink path. Okay, so this we have a cell, different type of cell network. This is coverage by this tower and all, and besides this we have a BSC or a MSC or a BSS. So this system BSS base station subsystem communicate to the MSC main switching centers, and also main switching centers communicate to this different types of the databases like SLR or VLR or EIR. So all this database maintain your services and where your locations and your mobile tower locations and the GPS, all these things are monitors in this database, and also your mobile equipment identification and your GPS locations. All these things are recorded in this database, and moreover your charging level and also your signal strengths, all these things are recorded. And how to say this, cell usage charge. Okay, your talk time, your SMS, your data packet, all these billing systems are maintained in this MSC. And moreover, if you are in a roaming or if you are in other service sale, so visitor locator register your informations, everything. And also MSC communicate to the PSTN network also, this normal telephone line. Okay, these are the mobile cell, okay, cell and mobile phone to communicate those mobile to the cell downlink part. Okay, this is a forward channel. Payload channels, asynchronous channels, and paging channel and forward traffic channels are there in these forward channels. Payload channel. Payload channel is refers to the channels which use the mobile stations to acquire the time and as a phase reference for the coherence demodulations. So in the communications we have modulations and demodulations. Modulations is the exchange into different carrier for the transmission. This is modulations, but at the transmitting end, it's converted it back this modulated signal into the original signal. This is called the demodulations. So it is this pilot channels is the mobile stations to acquire the time and as a phase reference for coherence demodulations. It is continuously transmitted by its base stations. So base stations are there, this BST transmitters continuous channel, okay, continuous channel at its active CDMA frequencies, and its mobile stations MS is our mobile phones track these signals continuously. Okay, so it's send out the pilot channels. Okay, is a reference channels, pilot channels or reference channels transmitted continuously from the BTS base station terminal. So our mobile stations tracking these signals continuously. So this is the pilot channel. Then the next one is the synchronized. Synchronized channels carry a single repeating message which give the information about the time and the synchronization configurations to the mobile stations. Likewise, the mobile stations can have the exact system time by the means of the synchronization to the short code. So after pilot channels is tracking with this MS of our mobile stations. Then after this is synchronized with this MS. Okay, it's synchronized. The mobile stations have can have the exact system times by the times of the synchronization to the short code. So we have a code to synchronize the time to communicate with the tower and the BSC and the MSC. So we need to have a synchronizations with the synchronization with the base stations. Okay, so this will maintain the time slot and the short code for the synchronizing with my mobile stations and the BST. Paging channel. Paging channel main objective is to send out page, that is notifications of incoming calls to the mobile stations. The base stations uses those pages to transmit systems overhead informations and mobile station specific message. Okay, so if we have an incoming call or a count out incoming call or any other informations, then the mobile stations, okay, there's some notifications are coming out. This is called the paging channels. And forward traffic channels. Forward traffic channels are code channels. It is used to assign call. Okay, not incoming, is assigned call. Forward traffic channel. Paging channel is for the incoming call. Okay, for the incoming call. And for the forward traffic channels, in this forward traffic channels are code channels. Okay, code channels. Then you have to dial the code, or you have to communicate with the BST, BSC, and next to the MSCs, or if you are going to out from the mobile network, then needed to go to this normal telephone line, then it's needed to switch to the PSTN network. All these things are the outgoing traffics. Okay, forward traffics. We need a code. Okay, we need a code channel. It is assigned to a call using voice and signal traffics to individual users. Okay, this traffic channel is very important for the outgoing traffic. Okay, let's move to the reverse channel. The reverse channel is the mobile to cell directions of the communications of the uplink part. Okay, what is the forward channel? Forward channel is downlink part. Okay, mobile to cell, and reverse channel is the uplink part. Okay, it consists of the following: access channels and reverse traffic. What is the access channels? Access channels is used by mobile stations to establish the communication with the base station, or to answer paging channels messages. The access channels is used for short signal message exchange, such as call up, response to page, and registration. Okay, access channel is what? Access channel is used by the mobile stations, our mobile phone, to establish a communications with the base station, BST, the tower, and the base switching center, BSC, nearby the device, tower nearby this equipment and all, or to answer the paging channels. Okay, paging channels is what? It's under the services of the forward channel. To answer those paging channel, the access channels is used for short signaling message exchange, such as call up, if you are stop the call, and response paging and registrations. So these are the things in the access channel. And the next point is the reverse traffic channels. Reverse traffic channels is used by the individual using their actual call to transmit traffic from single mobile station to one or more base station. Okay. Reverse traffic channels is used by the individual users, if it's the MS of a single user. Actual code to transmit from a traffic or a single mobile tower to one or more base stations. You can communicate the more base stations. Okay, base stations from the one mobile systems. So this is the reverse traffic. Okay, reverse traffics. If we access more than one. Okay. Okay, these are the CDMA digital cellular standard, and we are completed the unit 4, and next class we are going to uh, the next topics, next unit. This is the unit 5. Quantizations, diversities, and coding channel. This also not a very complex one. It's a small topics. We can cover it within a single class. Okay. Well, that's all for today. We'll continue it in the next class. Okay, let me call your roll number. Today is 21st September. 21st September. Roll number 2.
Present, sir.
4. 5.
Present, sir.
7.
Present, sir.
8. 9. 10. 11.
Yes, sir.
12. 13.
Present, sir.
14. 15.
Present, sir.
Okay, that's all for today. Next class we will continue the next unit.
Sir, roll number
Thank you,
10, present
sir.
aron teka.
Roll number 10 present.
Ano ma, aron chang telo niyo. Thank you, sir.
Any other question? No. Okay. Thank you all.
Thank you, sir.